Okay, so now the today's topic is data acquisition system. Today's topic is data acquisition system. So first one is a digital data acquisition system and another one is a analog data acquisition system. Means the data acquisition systems are of two types: analog data acquisition system and the digital data acquisition system. So now the question is, what exactly the data acquisition system? So data acquisition system is nothing but measuring the values or measuring the variables and storing that information, the measured variables, for future use is nothing but the data acquisition system. Means when we are taking one industry, we are measuring the variables in the industry. Let us suppose I would like to measure the temperature of a particular device. I would like to measure the temperature of a particular device in order to monitor that particular device, and I would like to save that particular data, the measured information, the measured temperature information in the recorders. Then I'm going with the data acquisition system. So there are two types of data acquisition system now, as we said. So the there are two types of data acquisition system. One is the analog data acquisition system, another one is the digital data acquisition system. Now the question is, what exactly the analog data acquisition system and digital data acquisition system, and when to use the analog data acquisition system and when to use the digital data acquisition system. So analog data acquisition system is nothing but when we are measuring the variables and storing the measured values in the analog form, then we are going with the analog data acquisition systems. And there are some situations in such a way that we should measure the values and save the values in terms of the digital. Then we are going with the digital data acquisition system. One is the analog data acquisition system, another one is the digital data acquisition system. So here, when to use the analog data acquisition system is a question. So the thing is, when we are having the vast bandwidth requirement and we are not concentrating that much on the accuracy of the system performance, then we are going with the analog data acquisition system. And when to use the digital data acquisition system means when the measuring variables are varying very slowly with respect to the time, when the measuring variables are varying slowly with respect to the time, and we are focusing more on the accuracy of the system performance, then we are going with the digital data acquisition system. One is the analog data acquisition system, another one is the digital data acquisition system. Okay, now, so what are the factors which are there in the data acquisition system is the question. Okay, now, that may be the analog data acquisition system or the digital data acquisition system. So here we are taking the analog as well as the digital now. So I'm going with the one of the example, means the components, general components which are going to be reside inside the data acquisition system. So for that we are taking this particular slide. So if you see this particular slide, the basic components which are going to be there, the basic components which are going to be there in the any data acquisition system are: one is a transducer, another one is a signal conditioner, another one is a scanner or the multiplexer. We call that one as a multiplexer. Another one is a signal converter, another one is a to D converter, another one is a digital recorder. So we may have the analog recorder also. So I think all of us know that there are means we have seen the seen about the recorders in third semester paper 3 4th unit. Okay, now recorders are there. Means there are the two types of recorders. One is a permanent recorder and a reproducible recorder. Permanent recorders are nothing but the XTXY recorder, and the reproducible recorders are nothing but the what we say, the magnetic tape recorders. Reproducible are nothing but the magnetic tape recorders. Means in the permanent recorders we can't reproduce the value, we can't reproduce the value. So simple example for the permanent recorders are the graphic. What is that? Graph. Plotting the the graph between the two variables on the paper, which is not going to be reproduced in the electronic format afterwards. Once you write the data on the paper, that's it. We can't reproduce that information back into the electronic signal. So that kind of recorders are called as the permanent recorders, and reproducible recorders are nothing but we are storing the data, and whenever you want you can reproduce that data into the electronic signal format. So that is nothing but the reproducible recorder. So the example for the reproducible recorder are our tape recorders, which we have seen. So we can call that one as the magnetic tape recorders also. Okay, so here we are taking the digital recorder. We may use the analog recorder also. Okay, So here these blocks means how to get the function, means how these elements which are residing in the data acquisition systems should get performed. That entire thing is going to be written in terms of the program, means how to control the activities of this block, this block, this block, this block, and how they should respond when some process is going on. So everything is going to be written in terms of the program, and that is going to be stored inside this particular block. That is going to be stored inside this particular block. Okay. So the thing is, we are having the transducer. This is the brief explanation about our scenario. Means this block is used for what we say. This block is used for controlling the activities of the individual blocks. Controlling the activities of the individual blocks. Now let's go for the explanation of each and every block which is there in a particular data acquisition system. So I'm using the transducer. What exactly the transducer? We know that one, right? What exactly the transducer? Transducer is nothing but it is a translator. Simple format, it is a translator. Or I can say that the transducers are used in order to convert the physical entities into the electrical signal format. For example, when you are going to measure some variables, sometimes the variables are available directly in the form of the electrical signals. Sometimes the variables are not available in the form of the electrical signals. For example, I would like to measure the the voltage of a particular device, means how much voltage drop is there. Then I'm going to use the multimeter and I'm putting that I'm using that particular multimeter. I'm going to measure that particular value. Means in this case, my variable is already available in the electronic signal. So at that time, no need to use the transducer. But if at all you have been asked for measuring the temperature of an environment, or temperature experienced by a particular device, or the temperature within the industrial element, it means the temperature within a particular area in an industry. Okay, means we are having the company, in that company in a particular block. I would like to maintain the temperature of that particular block in that particular company. So at that time, what we are going to do is we can't that temperature is not available in terms of the electrical signal format. So the temperature is a physical entity, right? The physical variable, so which is not available in the electronic signal format. At that time, what we are supposed to do, we are supposed to have someone which is going to be converts our physical value into the electrical format. Our physical value into the electrical format. Now the question is, do we have an element? Yeah, as you know, we already discussed in the third unit, third semester, third paper. So here the transducer, we have an element called as a transducer. What is the intention of the transducer? To convert the physical entity into the electrical format. To convert the physical entity into the electrical format. So that the next coming blocks, which are the working based on the electrical signal, they are going to be processed of a signal. The physical signal is going to be processed by the electrical signal. To do that one, we are supposed to use the transducer. So we have seen one example, I think during the third semester, we have taken one thing called as a LM35, which is a temperature sensor, acting as a transducer. So what is the use of the LM35? Which senses the temperature of the environment and converts that one into the electrical signal format. That electrical signal may be purely depends on the type of the transducer which we are using in our case. So means some of the devices are showing their output in terms of the voltage, some of the devices are showing their output in terms of the current, some of the devices are showing their response in terms of the frequency. So different output response means the information is going to be converted into the electrical format. That information may be in terms of the voltage, currents, or the frequency format. Okay, so that's why we are using the transducer. Means transducer is the one which is translating the physical information into the electrical signal format. After that, we are using the signal conditioner. So don't think that we are coming across a new terminology actually. So it is not at all the new terminology. So signal conditioner is nothing but it is a we are not coming across a new terminology. Signal conditioner is nothing but which is an instrumentational amplifier. So wait a minute. So it is an instrumentational amplifier. So instrumentational amplifier is a one. Instrumentational amplifier is a one. Instrumentational amplifier. Wait a minute. Because I want to know the time. Because while uploading the data on YouTube is taking more time. So I would like to see how much time duration I'm making the video. Okay, thank you. Okay, So signal conditioner is nothing but it is an instrumentational amplifier. Instrumentation amplifier, which we have studied in the instrumentation paper during the third semester. What is the instrumentation amplifier? So we know that we have the amplifier, right? What is the use of the amplifier? Which translates the weakened signal into the strengthened signal. Means without changing the characteristics of the input signal, it is strengthens the, or it is increasing the energy of the signal at the output terminal. So which is a normal amplification process. But the instrumentation amplifier especially used in the instrumentation systems which is next to the transducer, So means the signal conditioner is nothing but it is the instrumentational amplifier. Now the question comes that when the transducer is converting the physical entity into the electronic signal, what is the use of the instrumentation amplifier? Okay, now see ma, whatever the transducer which is used for translating the physical entity into the electronic signal, the output of the transducer is having the low intensity signal. Means the amplitude, the energy of that amplitude, or simple way is if the energy of the signal which is coming out from the transducer is going to be very low energy. Means that signal is having the is called as a low intensity signal. So here what we are supposed to do, in order to drive the information from one location to another location, the signal should have the proper amount of energy. If the signal is not having the proper amount of energy, as we know that when you are trying to transmit the data from one location to another location, if the signal, whatever the signal which is passing through the wire is not having the sufficient energy, then obviously at the destination we are not going to receive the actual data. At the destination we will come across the altered data, which is not the actual data which is available at the output of the transducer. So that's why when you are trying to transfer a data or a signal from one location to another location, between the transmitter and receiver, as we know this one, right? So between the transmitter and receiver, we should use the amplification process. What is the use of the amplification? At the destination, we are expecting that same signal which is available at the output of the transducer. If you are not using the amplifier, here are somewhere the signal is going to be get altered. Means if you are talking in terms of the digital format, when you are driving the information from one IC to another IC, then what will happen? If you are not using the buffers between the source IC and the destination IC, then obviously zeros are going to be becomes the ones are going to be becomes the zeros at the destination. So to overcome that one, we are using the amplification process. So here the instrumentation amplifier, whatever the signal condition we are having, this is called as a instrumentational amplifier. So instrumentation amplifier is main intention of the instrumentation amplifier is to amplify the weakened signal into the strengthened format. Which is placed next to the transducer. So here, if your transducer is very next to the destination, no need to use the signal conditioner actually. If it is very next to the destination and the destination is satisfying the information given by the transducer, then no need to use the instrumentation amplifier, which is nothing but the signal conditioner. But when we are going for the industry, let us suppose, as I said, I would like to maintain the temperature of a particular area in the industry at certain degrees centigrade. For example, it is 100 degrees centigrade. Is it possible to the human being to measure that value by going to that area? It's highly impossible. If you are trying, then you are going to burst. Means you are going to become the hash. Okay, now. So to overcome that one, what we are supposed to do? We are using the transducers. And at the same time, we can't use the instrumentation amplifier. The entire data acquisition system. We can't place the entire data acquisition system at the particular high temperature. Because the devices are not that much bearing capacity. They are not having that much bearing capacity of temperature. Or I can say that their characteristics are going to be changed when they are working under the high temperature. Okay, so that's why what we are supposed to do, we are not going to have the data acquisition system next to the environment where we are measuring the 100 degrees Celsius temperature. So that's why we are using the transducer. We are using only the transducer at the the environment at the measuring point, and we are transmitting that information to the destination. We are transmitting that information to the data acquisition system, which is there in the control system. Or we used to call that one as a base system in the aerospace, we call that one as a base system, but in our case we call that one as a control room. Simple way is a control room. So when you would like to measure the information in one area, transfer that information to the control room, then then the path which is going to be used for transmitting the data is going to be very long. And because of that, what we are supposed to do, we are supposed to use the amplifier. So that is nothing but the instrumentation amplifier. If you are not using the instrumentation amplifier in this case, then definitely whatever the data which is sensed by the transducer at that particular environment is not going to be sense the same information to the data acquisition system. Okay, so that is the main intention of the signal conditioner. After that, we are having the scanner, which is also called as a multiplexer. Means when we are taking one industry, I would like to know the different. I would like to know the parameters, different types of parameters in a particular environment. Means, let us suppose I'm having one industry. In that, I would like to measure. There are certain situations. Means, I would like to maintain the temperature of so and so area. At the same time, I would like to maintain the pressure of some element. Means the pressure experienced by a particular element. I would like to keep on what we are supposed to do. I would like to keep on track that information, store that information. Okay, how the means how much pressure is experienced by that particular system. I would like to keep on track that one and store that one for the future use. Okay. At the same time, we may have the measuring the stress experience or strain experience by an element. So for there we are going to use the strain gauges. Means in a particular industry, we not only concentrate on one element, one variable measurement. We will come across the multiple measurements. Means we are going to measure the multiple variables, and those multiple variables should be collected and stored inside the data acquisition system. So means multiple sources are there. At a time we can store one variable. Okay, now so in order to choose a particular variable out of many variables, we are using the multiplexer. Means we are using only one data acquisition system, and we are going to assign the time slot for each and every variable. Means let us suppose I would like to measure the temperature, I would like to measure the pressure, I would like to measure the strain and other things. Okay, now other physical parameters which you would like to measure. So you can measure them and you can store them in the data acquisition system. But what we can do is, we can't store each and every variable information at a time, because we have only one data acquisition system. So at a particular, let us suppose I'm having the 1 minute of time span. I would like to measure the 4 variables. I would like to measure the 4 variables and store that information in the data acquisition system. Store that information in the data acquisition system. At that time, what I'll do is, I'll take the 1 minute time duration. In this 1 minute time duration, for first 15 seconds to the one variable, next 15 seconds to the another variable, 15 seconds to the another variable, 15 seconds to the another variable, again come back to the first variable. Okay, means I'm going to use the multiplexer. It is just like a it is for storing the information, but we can also take the multiplexer in case of our television. So when we are having the TV at home, obviously we are going to have the hundreds of channels at the input of the our set-top box. So, but we are tuning to a particular channel with the help of the remote. Okay, so that's why we are having the multiplexer. Okay, multiplexer means selecting one out of many. Simple format, selecting one out of many. This much of explanation is not required, but in industry, we are not coming across only measuring only a particular element. We will come across so many elements. So that is the intention of this much of explanation. And after that, we are having the signal converter. The signal converter is nothing but when you are taking the when you are trying to send, we have seen this explanation. When we are trying to send one information from one IC to another IC, when we are trying to send one information from one IC to another IC, don't think that means you can directly communicate one device with another device directly. You can't do that one. When you would like to send the information from one IC to another IC, the output of this first IC, which would like to send the information, should match with the characteristics of the input of the second IC. Okay, or first device and the second device. If the characteristics between the output of the first device and the input of the second device both are not matching, then definitely whatever the data you are going to send, that is not going to be matched. That is not going to be matched between the means that is not going to be collected by the destination, second IC or the second device. Okay, so at that time what you are supposed to do, before communicating or before connecting any device with another one, you should thoroughly check out what are the output parameters, means how the output parameters are going to be there from this particular device. Are those output parameters are satisfying the characteristics of the inputs of this particular device? If they are not matching, then what we are going to do? We are going to take the mediator. We are going to take the mediator. Okay. So here, we are going to take the mediator. The means when you are taking the mediator takes the responsibility to take the output from the first device and convert that one into the understandable format of the second device. So that mediator is nothing but, sometimes if you are taking the serial communication, we are using the MAX232. We are using the MAX232 because without using the MAX232, it is highly impossible to convert to transmit the information between the ICs. Okay, between the personal computers, which we have seen in the serial communication of the microcomputer. So I'm not going microcontroller. I'm not going to touch that one. But only the thing is, when you would like to communicate one device, connect one device with another device, then the output characteristics of this device should satisfy the input characteristics of this device. If they are not satisfying, then we are going to take the mediator. That mediator takes the responsibility, listens the first device, transmits the information to the second device in the understandable format of the second device. So that's the main intention of the signal converter. Means whatever the information which is there at the output of the multiplexer, means this information may or may not be understandable by the analog to digital converter. So that's why, in order to drive the information to the to a particular level which can be understood by the analog to digital converter, we are using the signal converter. If at all the output of this one is matching with the input of this one, then no need to use the signal converter. So that's the main intention of the signal converter. So analog to digital converter, obviously here we are using the digital recorder now. So because of that, we require the analog to digital information, because whatever the output we are getting from the transducer, it is not the digital information. The output coming from the transducer is not the digital information, it is the analog information. Okay now. So it is keep on processed, and when you would like to store that information in the digital format, so obviously the analog information should be converted into the digital format. If it is not done, then definitely your recorder is not going to store the data. And all these parameters, these blocks are going to be controlled by this programming block. Means we are writing the program pre-programmed application, and we are dumping that one into this block, and we are expecting the operation from this particular from this particular analog data acquisition system. And some of the parameters may or may not exist when you are going for the reality, but it is a overview of the analog data acquisition system. And here you can also use the same concept for the digital data acquisition system, but in this case, as the data is storing in terms of the digital format, I can say that it is a digital data acquisition system, which is storing the information in the digital format. But when to use the analog, when to use the digital, we have seen in the initial class, so I'm not repeating that one. Okay, so this is the scenario. Now we know the transducer, right? Transducer means which translates the physical information into the electrical signal format. The physical information may be the temperature, the physical information may be the pressure, the strain, whatever the scenario, whatever the physical parameters which we would like to measure, that is going to be converted into the electrical format. Now another case is a signal conditioner, so which is an instrumentation amplifier, which is already covered in our third semester, third paper. So here I am going to give an overview about the signal conditioner, which is nothing but the instrumentation amplifier. As we come across this particular signal conditioner block, let me give a brief explanation about the signal conditioner, which is nothing but the instrumentation amplifier. So here the instrumentation amplifier is having the separate characteristics compared to the normal operational amplifier. Means you can't use the normal operational amplifier in the data acquisition system other than the instrumentation amplifier. So why I can't use that one? I'll let you know. Wait. So here the instrumentation amplifier. The instrumentation amplifier is going to be, what it is doing, it is sensing the information, it is accepting the weakened signal and converting that one into the strengthened format. So in this instrumentation amplifier, I'm having the two inputs. These two are connected to the non-inverting terminals of the op-amp, and at the output of these two inputs are given as an input to the differential amplifier. And at the output we are getting the strengthened signal. weakened signal is given, and at the output we are collecting the strengthened signal. So for this one we are having the mathematical calculations which we have seen in the third semester also, but for right now I'm not going to cover that one. Just go to the textbook because we already done with the instrumentation amplifier. So the instrumentation amplifier is connected between the transducer and the next block, between the transducer and the next block. That block is nothing but, as per this one, it is a signal conditioner block. As per this one, it is a signal condition. Signal conditioner block is placed between the scanner and the transducer. Okay. So here, let me show you that when you would like to interface your instrumentation amplifier, when you would like to interface the instrumentation amplifier to the transducer, make sure that in general, make sure that the distance between the transducer and the instrumentation amplifier is very short one. Means you should be able to communicate the transducer output with the instrumentation amplifier using a short wire connection. You can't use the long wire. Why? When you are trying to use the long wire to communicate with the means to transfer the information from the transducer to the instrumentation amplifier, what will happen is, here we are going with the industry now. In the industry, we will come across the electrical components which are working with the high voltages, At that time, what will happen? See, whatever the data acquisition system which we are using, it is a low signal devices. They are not the high signal devices, but in the industry, we will come across the high signal devices, like we are using high voltage devices. Okay, now. So those devices may affect the signal transmitted through the wire from the transducer to the instrumentation amplifier. Means that high noisy signals, I can call them as a the devices which are working with the high voltages. They are creating the noise in terms of the radiation. In terms of the what current loop grounds, with respect to the ground, they are forming the current loops also. Okay, now, and those signals may get induced into the wires which are communicating the transducer and the instrumentation amplifier. At that time, we will come across, means in the instrumentation amplifier, means at the output of the instrumentation amplifier, whatever the information we are getting, it's not the actual one. It is a signal which includes the noise also. Now the question comes up: how to overcome these particular noises which are going to be induced into our system as a noise? How to rectify this particular problem is a question. So to do that one, what I'm going to do is I'm going to use this kind of setup. Okay. So here I'm going to take the output from the transducer, which is going to be given as an input to the next level, which is the instrumentation amplifier. I'm using the two parallel wires. Means when you are unable to connect your instrumentation amplifier using the very short wires to the transducer, if you are not doing that one, then obviously the noises are going to be introduced into the wires, and they are going to be affect the actual variables information, okay, which are going to be affect the actual information. So to overcome that problem, what we are doing is we are taking the two wires. Okay. So when you are taking the two wires, these two wires are arranged in such a way that whatever the noises which are introduced by the high wires, means high voltage wires or some other noisy signals, these two wires are connected in such a way that they are going to be induced as the noise into the wires equally. Means in this wire as well as in this wire, whatever the amount of noise is introducing, it is going to be introduced same here as well as here. Means both wires are carrying the same signal. Both carriers are carrying the same noisy signal. Okay. So when both signals are carrying the same noisy signal, when it is given as an input to the instrumentation amplifier, what will happen? Inside the instrumentation amplifier, the beauty of the instrumentation amplifier is it is having the high impedance differential input. So when the two signals, when the noisy signals are introduced into the wire and they are equal in both wires, they are equal in both wires at that time, at the destination, as it is having the what is that high impedance differential input as well as a high voltage rejection ratio, common mode rejection ratio. Okay, now we are having the differential yeah, common mode rejection ratio, CMRR, common mode rejection ratio, and because of the common mode rejection ratio of the instrumentation amplifier, which is having the high in value, it is going to be nullifies equal values. Means when we are having the common signal in both wires, that is going to be nullified by the instrumentation amplifier. Instrumentation amplifier, as it is having the common mode rejection ratio, high common mode rejection ratio. Because of that, the noise signal which is introduced in this one as well as this one both get cancelled. So at the output we are going to get only the actual signal, not the noisy signal. This one also means it is going to be considered up to certain range. Means we can't give the guarantee that instrumentation amplifier is also going to be nullifies the noisy signal that much, because there is a chance of a noisy signal is going to be very noisy signal carried from in one wire and in another wire may be differ. At that time, at the output of the instrumentation amplifier, again we will come across the noisy signal. So to overcome that one, instead of doing all this setup, what I'm going to do means, whatever the cable I'm using between the transducer and the instrumentation amplifier, I'm going to protect that particular wire. I'm going to protect that particular communication path. We used to call as a guarding the wire, or I can say that in simple format, in the communication format, I can call it as a jacket. I'm going to use the a cover on the wires, okay, which we call it as a guard or jacket. Okay, so what this jacket will do means, it is just like this. It is just like a jacket is nothing but we are protecting ourselves from the rain. So using the raincoat, just like that, we are protecting our actual communication lines using the extra covering element. We call this one as a shield, or we can't see this one as a guard, or we can call this one as a jacket. Simple example, if you want to get, I think all of you would have seen this this kind of protection in your TV connections. So cable connection, this connection you are using the one wire now, we call that one as a coaxial cable. So when you are taking the coaxial cable, we are having the core as well as the cladium, that is going to be get protected by the block wire, that is going to be get protected by the block layer in that where we are having the two layers. So on the top of that one, on the top of these two layers, we are having the one block layer. So that is nothing but the jacket, which is protecting the actual wire, which is protecting the carrying wire, data carrying wire. Okay, now so here also I'm using the a shield to protect my wires. Okay, so what this shield will do means, here also, even though we use the shield, don't think that the noisy signals are not going to be involved. The noisy signals are going to be involved. I'm assuming that this noisy signal is going to be connected to one wire, and another wire is connected to what? Another wire. The one wire is connected, coming across the resistance and capacitance, which means introducing of the noise into the system, which is going to be communicated with one wire, and another wire is connected to the the shield. Another wire is connected to the shield. Another end of this shield is connected to the instrument case. And obviously the instrument case is already grounded. So whatever the noisy signals and the electronic current signals or the noisy signals which are going to be bypassed to the ground, means it is not only affecting the information, sometimes we will come across the shocks also. If you are touching one, let us suppose you are doing the experiment on a particular device, if that particular device is not grounded properly, then here are some way there is a current, means you are going to experience the shocks on the equipment. When you are touching the equipment, you are experiencing some shock. It's just because your grounding is not proper. Okay, so to overcome that one, what you are supposed to do, you should be very much careful about your ground. Means whatever the high voltage signals which are coming and interacting with the devices. At that time, sometimes the device is going to be what is that? It is not going to be burst, but it is going to be safe only. But when the human beings are going to be touched that one, they'll feel the jerk. Okay, they'll feel the shocks. So to overcome that one, what we are supposed to do? The case of that particular device is connected to the ground. The case of that particular device is connected to the ground means we can protect the user. We can protect the user. Okay, because when you are how we can protect the user means whatever the what high voltage signals which are coming from the other areas, that is going to be bypassed to the ground. Okay, so this is one way of protecting our what is that, devices, and protecting our devices from the high voltages, as well as protecting ourselves from the shocks when you are touching the measuring system. And also this is another way, another way of means using the shield over the line, over the actual wire. It is going to be protect our what is that, signal, which is transmitted from the transmitter. Here the T is nothing but the transmitter. I don't have the symbol, otherwise I would have included the transmitter symbol right over here. I'm just representing the T. Wherever you are seeing the T in the diagrams, just feel that it is a transmitter. Okay, so you are communicating the transmitter with the next level of the device, that is nothing but the instrumentation amplifier, but here we are not showing that one. It's kind of communicated. So whatever the communication path we are using, that communication path, if at all both the wires which are used in the communication path are introducing the means allowing the noise to induce it into the wires equal format, then no need to use the means, no need to bother about the shield. But if at all it is not doing like that, then definitely we are supposed to use the shield, which is protecting our cable from the external noisy signal, picking the noisy signal. So that is the use of the shield. Okay, so the next case is we have another method also. As I said, when you are going to use the what is that, the instruments directly, there are chances in such a way that we will come across the what is that, the current shocks. We'll come across the current shocks. Okay, we'll come across the current shocks. To overcome that one, what we are supposed to do, we have seen one thing. One example, I think we have seen one device in our third semester, third paper again. Don't think bad every time I'm calling the previous classes, because we already done. We have done a depth analysis during the third semester. There we have the board and we have gone for the complete explanation. But here I don't have the facility of board. So isolation. What is the use of the isolation amplifier? Where we are using the isolation amplifier? Most of you know that one, right? So the main intention of the isolation amplifier is isolating certain devices from the direct connections. When you are using the isolation amplifier between the devices as a connector, then this particular isolation amplifier is going to be isolates the one device with respect isolates one device from other device. It is going to be isolates one device from other devices. So the best application of the isolation amplifier is which we are using in the medical field. So whatever the measuring instruments we are using to measure the certain parameters of the patient, we are not communicating the, we are not connecting the measuring devices directly to the patient. If we are doing like that, if we are communicating the device directly to the patient, here are some way, because of some drawbacks, because of the some noisy signals picked by the measuring system. That noisy signal may be the high voltages that is going to be bypassed to the ground via the patient at that time. Instead of doing the curing, the patient is going to get die. Okay, now so to avoid that one, we are isolating the instrument as well as the measuring system. We are isolating the instrument from the patient. Okay, using the isolation amplifier. So isolation amplifier is going to be means one side of the isolation amplifier is connected to the patient and another side is connected to the measuring system. If at all there are certain high voltages coming from the measuring system because of the certain problem like grounding, all those things, it is not going to be bypassed to the ground via the patient. It is going to be isolating. Okay, so that is the main use of the isolation amplifier. So here also, when you are coming across so much of problems, means even though you use the proper connecting wires and they are allowing the equal noisy signals, and that the equal noisy signal is going to be nullified by the isolation amplifier because of the common mode rejection ratio. sometimes means if that is not satisfied, we are going with the a wire which is protected by from the external. Means we are using the wire with the shield. We are using the communicator wire with the shield. So at that time also it is going to give the proper response. Means it is let us suppose it is protecting the wire. The shield is protecting the wire, but here are somewhere we may come across the jerks. There's a current shocks when there's some person is going to be touches the measuring system. To overcome that one, what we are supposed to do means we are going with one thing called as a isolation amplifier. I'm sorry I didn't prepare the slide for this one because it's very difficult. I don't know the certain softwares. So because of that, I'm just picking the what is the snap of the textbook. So here I'm using the isolation amplifier along with the balanced modulator. So here I'm taking the over here we are using the transducer. The output of the transducer is given as an input to the instrumentation amplifier, and this particular instrumentation amplifier output, the instrumentation amplifier which is next to the transducer, is given as an input to the balanced modulator. The balanced modulator. I'm assuming that in this case it is only the assumption. I'm assuming that the output of the amplifier is a DC signal, a DC voltage, and I would like to amplify that signal. And means in order to strengthen the signal, we should amplify that signal, and transfer the information to the long distances. What I'm going to do means I'm going to use the balanced modulator. This balanced modulator, in order to amplify the DC signal, we don't have the direct amplifiers to amplify the DC signals. Okay now. So what we are supposed to do means DC signal should be converted back into the continuous signal. DC signal should be converted back into the continuous signal, and the continuous signal is going to be continuous signal. That is a wave for having certain frequency. So that is going to be that is going to be means we can amplify the AC signal in the perfect way compared to the DC signal. So that's why I'm converting the DC information into the square wave format with the help of the balanced modulator. So right over here, I'm demodulating the output of the modulator using the demodulator. I'm using the modulator as well as the demodulator. Same signal is constructed back at the destination. So the main intention of the isolation amplifier means amplifying certain signals. So here we are not using the amplifying the DC signal is not going to be done by the isolation amplifier. Actually, we are using the chopper amplifier, which we have seen in the third semester. So we are using the chopper amplifier, but I'm not explaining that entire thing. But the same chopper amplifier concept is included right over here. The same chopper amplifier concept is included right over here. Okay. So here the what we are having, the chopper amplifier, which is amplifying the signal, and at the output of this one we are going to get the DC signal again with the high intensity. Means the strength of the signal is going to be vary from here to here. And here I am using the isolation. Means there is no direct contact between the from one device to another device. During the third semester, we have seen the isolation amplifier using the optical fiber communication. There we are using the LED. Okay, now so we have taken the optical device. So means we have taken one device. I think which one is a photodiodes. Yeah, we have used the photodiodes. So with the help of the photodiodes, we transmitted the information from one device to from one device output to the another device input without having any contact, which we have seen in the third semester. If you want, you can go back. So this is the isolation amplifier. So when you are facing the problems in communicating the what we say means when there are high voltage involvement, current shocks, current jerk when you are touching the measuring device. To overcome that one, what we are going to do is we are going to use the isolation amplifier. I think this